What would happen if one of the brightest and most enigmatic stars in the night sky were about to change forever? Betelgeuse, the imposing red supergiant in the constellation Orion, has fascinated humanity for centuries. Its reddish light easily stands out among the others, and its unpredictable behavior has sparked the curiosity of astronomers and enthusiasts for generations. But what secrets does this stellar colossus really hide? And why does the scientific world go on high alert every time its brightness changes? Betelgeuse is not just another star in the firmament. It is a true giant on the verge of culminating one of the most spectacular stages in a star's life. To give you an idea, if it could take the place of the Sun, its surface would extend beyond the orbit of Mars. But how is it possible that such a distant and seemingly tranquil star can influence the history of astronomy so much? What makes it so special among the billions of stars that populate our galaxy? Throughout history, Betelgeuse has been a beacon for navigators, a source of inspiration for myths and legends, and a natural laboratory for modern science. Its name resonates in cultures from different times and places, and its study has allowed us to better understand the cycles of birth, life, and death of the most massive stars in the universe. However, it still holds mysteries that challenge even the most advanced telescopes and the brightest minds in astrophysics. Today, we delve into the life of Betelgeuse to discover why it is one of the most monitored and studied stars in the sky. From its impressive size and chemical composition to the hints suggesting it might be nearing a spectacular end, every aspect of this red supergiant brings us a little closer to understanding the most extreme and fascinating processes occurring in the cosmos. Are we ready to witness up close the fate of such a monumental star? That is the question that invites us to look once more to the sky. Where is Betelgeuse, and how can we recognize it among the millions of stars that adorn the sky? Betelgeuse occupies a privileged place in the night sky. It is the star that shines brightly on the left shoulder of the recognizable constellation of Orion, the Hunter. But how can we know that we are really looking at Betelgeuse and not another star? The secret lies in its color and the arrangement of the stars around it. When observing the constellation of Orion, it is easy to identify its characteristic hourglass shape, marked in the center by the three aligned stars that form the famous Orion's belt. Betelgeuse is located above and to the left of that belt, in a position opposite Rigel, the other bright star of Orion, which is found below and to the right. Betelgeuse stands out immediately due to its reddish-orange hue, an uncommon color among the stars visible to the naked eye, making it a kind of celestial beacon. If you have ever wondered which star seems to glow softly on Orion's shoulder, that is Betelgeuse. And why is it so easy to see? Unlike many stars that barely twinkle in the distance, Betelgeuse is one of the brightest in the night sky. On a clear night, even from a city, it is usually visible without the aid of telescopes or binoculars. In fact, if we draw an imaginary line from Orion's belt and extend it upward and to the left, we will arrive directly at Betelgeuse. This simplicity in locating it has led different cultures for centuries to identify Betelgeuse as a reliable landmark in the sky. But what happens at different times of the year? Betelgeuse is especially prominent during the winter nights of the Northern Hemisphere, when Orion dominates the sky. However, its position relative to the horizon varies as the months progress, and depending on the observer's latitude. In the Southern Hemisphere, Orion appears inverted, but Betelgeuse still occupies a prominent position, being a red beacon that never goes unnoticed. Thus, no matter where you are, locating Betelgeuse is an invitation to look at the sky and discover one of the most fascinating gems of the celestial vault. Did you know that the name Betelgeuse hides centuries of history and linguistic misunderstandings? If you've ever wondered where this peculiar name comes from, the answer takes us back to the ancient Arab astronomers and the interpretative errors that have accumulated over time. The term Betelgeuse has its roots in classical Arabic, but its journey to the form we use today is a tale of translations, erroneous transcriptions, and cultural adaptations. Originally, The name comes from the Arabic Yad al-Jawza, which means the hand of Jawza. Jawza was the name that Arab astronomers gave to the constellation of Orion. Why the hand? Because Betelgeuse represents the hand or shoulder of the figure of Orion. However, during centuries of transliterations into Latin and other European languages, the initial Y was confused with a B, transforming Yad into bed and then into Bet. Thus, almost accidentally, the name Betelgeuse was born. But the story doesn't end there. Over time, European scholars attempted to decipher and adapt the Arabic names of the stars, often without fully understanding their original meaning. In the case of Betelgeuse, some medieval manuscripts referred to it as Beit al-Jawza, which translates to the House of Jawza, another erroneous interpretation that ultimately influenced the final word. It's fascinating to think that the simple stroke of a letter, or a hasty interpretation, can change the identity of such a famous star for generations. So why did that strange and foreign name persist in European languages? The answer is that, over time, Betelgeuse became recognizable and unique, setting itself apart from other stellar names. Its mysterious sound and peculiar spelling fueled the interest and imagination of both astronomers and poets and storytellers. Today, when we mention Betelgeuse, we are pronouncing an echo of ancient tongues and the shared history of astronomy, where each name encapsulates a blend of science, culture, and chance. Thus, the name Betelgeuse not only identifies one of the most famous stars in the night sky, but also stands witness to how human knowledge travels, transforms, and reinvents itself over the centuries. The next time you hear its name, remember that it is much more than a label. It is the trace of a long chain of cosmic observers, each contributing a small error, an adaptation, or a story to the grand book of astronomy. What makes Betelgeuse so special among the stars in the night sky? To begin with, its size is truly colossal. If we could place Betelgeuse at the center of our solar system, its surface would extend beyond the orbit of Mars and could even reach that of Jupiter. This means that Betelgeuse is hundreds of times larger than our Sun. However, despite its enormous volume, it is much less dense. Its matter is so spread out that a teaspoon taken from its atmosphere would weigh only a fraction of what a teaspoon of the Sun weighs. How much mass does such a gigantic star possess? Betelgeuse has approximately 10 to 20 times the mass of our Sun. Although this may seem like a vast difference, its size is disproportionately greater compared to its mass, making it an extremely inflated gas sphere. This characteristic is typical of stars in the final stages of their life, when they begin to expand and cool down. And how far is this cosmic titan from us? Betelgeuse is located about 640 light-years from Earth. What does this mean? The light we see today from Betelgeuse left that star at a time when Galileo was still gazing at the sky. On a cosmic scale, it is a relatively close neighbor, which explains why it is so visible and bright to the naked eye, despite the existence of much smaller stars located at much shorter distances. Now let's talk about its luminosity. Betelgeuse shines with an astonishing intensity. It is between 10,000 and 100,000 times more luminous than our Sun. It is so powerful that if it were as close to Earth as the Sun, its light would be blinding and devastating for our planet. This immense brightness is the result of the energy released by the nuclear reactions occurring in its core, and it is what makes it one of the most recognizable beacons in the night sky. However, this brilliance is also a symptom of the star's instability. Betelgeuse is living its final chapters before an explosive fate. With this basic information, Betelgeuse reveals itself to us as a true giant in the firmament. Massive, enormous, powerful, and at the same time, ephemeral in the vastness of cosmic time. Its physical characteristics not only spark our curiosity, but also remind us of how dynamic and surprising the universe we live in is. What makes a star a red supergiant? And why does Betelgeuse belong to this select group? To understand this, it is first essential to know that not all stars are the same. Some, like our Sun, live relatively stable and calm existences for billions of years. However, others are born with a colossal mass, which condemns them to a brief and spectacular life. Betelgeuse is precisely one of these gigantic stars, currently in an advanced stage of its evolution, the red supergiant phase. But what do we mean when we talk about a red supergiant? In simple terms, a red supergiant is a massive star that has exhausted the hydrogen in its core and, as a result, begins to burn heavier elements, expanding enormously. If we could compare stars to people, red supergiants would be the titans in their old age. They have grown so much that they can be hundreds or even thousands of times larger than the Sun, but at the same time, they are in the final stage of their stellar life. Their reddish color is due to their relatively low surface temperature compared to younger and hotter stars, which causes them to radiate that characteristic hue. How do red supergiants differ from other giant stars or red dwarfs? The key lies in their mass and the magnitude of their expansion. Red supergiants are true cosmic colossi, with masses at least 10 times greater than that of the Sun and diameters that could exceed the orbit of Mars if they were placed at the center of our solar system. In contrast, red dwarfs are small and long-lived, while giant stars, although large, do not reach the colossal dimensions of supergiants. It's like comparing a mountain to a hill and a rock. They are all part of the same family, but their size and impact on the landscape are radically different. Why is it so interesting to study red supergiants like Betelgeuse? These stars play a fundamental role in the cycle of matter in the universe. At the end of their life, they expel enormous amounts of material into space that enrich the interstellar medium with heavy elements, paving the way for the formation of new stars and planets. Additionally, their final fate is often a supernova explosion, one of the most energetic and transformative events in the cosmos. In short, red supergiants not only mark the twilight of a star, but also sow the seeds for the birth of new stellar generations. Did you know that the reddish glow of Betelgeuse is just the tip of the iceberg when we talk about its composition? Unlike our Sun, which is primarily a sphere of hydrogen and helium, Betelgeuse is a true cosmic laboratory where heavier elements are forged as the star ages. But how do astronomers know what is really inside a star that is hundreds of light years away? The answer lies in the light that reaches us from it. Each chemical element leaves a kind of unique fingerprint in the light it emits or absorbs, known as a spectrum. When scientists analyze the light from Betelgeuse through a spectroscope, they can identify specific lines that correspond to different elements. Thus, they have found that, in addition to hydrogen and helium, Betelgeuse is abundant in elements such as oxygen, carbon, nitrogen, silicon, and magnesium. This occurs because inside it, extreme temperatures and pressures allow nuclear fusions that create new elements, a fundamental process for the chemical evolution of the universe. But what happens when these elements are formed? In a simple analogy, we could imagine Betelgeuse as a huge cosmic oven, where the basic ingredients combine and transform into increasingly complex compounds. When the star expels some of its material into space, it is literally sowing the cosmos with atoms that, in a distant future, could become part of planets, comets, and even new forms of life. Thus, Betelgeuse not only shines, but also actively contributes to the chemical richness of the galaxy. An interesting fact is that, thanks to the observation of spectral lines, scientists can even estimate the relative amount of each element in the atmosphere of this star. For example, it has been detected that heavy metals, such as iron, are present in smaller proportions than in the Sun, but still play a crucial role in stellar dynamics. This spectroscopic analysis allows us to reconstruct the chemical history of Betelgeuse and understand how massive stars are the main factories of the elements that make life as we know it possible. Can the chemical composition of Betelgeuse change over time? Undoubtedly. As the star progresses in its evolution, the outer layers become enriched with products of nuclear reactions occurring in the core. This cycle of creation and expulsion of elements is one of the main engines of the evolution of the universe. In summary, studying the chemical composition of Betelgeuse not only helps us understand how a red supergiant works, but also reveals the deep connection between stars and everything that exists in the cosmos. What makes Betelgeuse so special in its life as a star? It all begins with its origin. Betelgeuse was born from a gigantic cloud of interstellar gas and dust collapsing under its own gravity. Unlike smaller stars like our Sun, Betelgeuse accumulated a much greater amount of mass from the very beginning. Why is this relevant? Because the mass of a star determines how quickly it lives and dies. Massive stars like Betelgeuse consume their nuclear fuel at a dizzying rate, like a bonfire ignited with gasoline instead of firewood. Once Betelgeuse began hydrogen fusion in its core, its life was intense but brief compared to less massive stars. However, what happens when the hydrogen runs out? This is where the story becomes even more fascinating. The star starts to fuse helium and then increasingly heavier elements, such as carbon, oxygen, and neon, in a sort of nuclear matryoshka, where each layer burns at different stages. This process causes its size to expand colossally, transforming it into the red supergiant we admire today. But the evolution of Betelgeuse doesn't stop there. Inside, the fusion of lighter elements gives way to more complex and violent reactions. Each new fusion phase lasts less time than the previous one, until finally the core fills with iron. Why does iron mark the end? Because fusing iron does not release energy, but consumes it, which means Betelgeuse can no longer support itself against gravity. All that balance that kept it stable begins to crumble. So, what is the final destiny of such a star? When the iron core reaches a critical limit, it collapses suddenly and triggers a monumental explosion, the supernova. This will be the fate of Betelgeuse, an event so energetic that for a few days it could shine brighter than the entire galaxy in which it resides. After the explosion, only the compact core will remain, possibly turned into a neutron star. Such is the life cycle of a massive star: brief, explosive, and fundamental for seeding the universe with new elements. How big can a star get? When we think of the Sun, we often imagine it as something immense, but in reality, it is a modest star compared to true giants like Betelgeuse. This red supergiant defies all intuition about size in the universe. Its diameter is so extraordinary that it is hard to comprehend. If we placed Betelgeuse in the position of the Sun, its surface would extend beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and even the red planet. In other words, the inner solar system would be completely within its gigantic sphere of plasma. But how much larger is Betelgeuse compared to our Sun? While the Sun has a diameter of about 1,400,000 kilometers, Betelgeuse's is estimated to be around 1,000 times greater. Imagine a sphere that, instead of fitting on a sheet of paper, would need to occupy the space of a stadium, but on an astronomical scale. To put it in perspective, if the Sun were the size of a soccer ball, Betelgeuse would be a sphere as large as an entire stadium. This difference is not only staggering, but also reminds us of how diverse the cosmos can be. Is Betelgeuse the largest of all known stars? Surprisingly, the answer is no. While it is among the largest observable with the naked eye, there are other supergiants even more colossal, such as VY Canis Majoris or UY Scuti, whose dimensions surpass even those of Betelgeuse. However, what makes Betelgeuse special is that, despite its vast size, it is relatively close to Earth, allowing astronomers to study it in greater detail than other more distant supergiants. Now, how do scientists measure the size of such a distant star? Unlike planets, stars do not have a defined edge, but a diffuse atmosphere that extends over millions of kilometers. Astronomers use advanced techniques like interferometry, combining the light from several telescopes to see details impossible to capture with a single instrument. Thanks to these methods, it has been estimated that the radius of Betelgeuse varies as the star pulsates and expels material. But even at its smallest moments, it remains a true giant, compared to the Sun. This comparison of sizes not only impresses with its scale, but also invites us to reflect on the diversity and grandeur of the stars that populate our galaxy. Betelgeuse is a reminder that, in the universe, there is always something much larger than we can imagine. What makes Betelgeuse shine with that characteristic reddish hue that distinguishes it in the sky? The answer lies in its surface temperature. While our Sun has a surface temperature of about 5,500 degrees Celsius, Betelgeuse's surface is considerably cooler, hovering around 3,400 degrees Celsius. This difference may seem small from a terrestrial perspective, but in astronomical terms, it is fundamental. The cooler a star is, the redder it appears to our eyes, and the hotter it is, the bluer it looks. Why does color depend on temperature? Stars are like gigantic balls of gas that emit light due to their heat. Just like a metal rod that first turns red and then white when heated in a forge, stars reveal their temperature through their color. Betelgeuse, being in the range of the lowest temperatures for a star visible to the naked eye, predominantly emits red and orange light. This is why it stands out with a warm glow among the other stars in Orion, many of which exhibit bluer or whiter colors. Is Betelgeuse's surface temperature stable? In reality, no. Betelgeuse is a variable star, meaning its brightness and surface temperature can fluctuate over time. These variations are partly due to internal pulsations that cause the star to expand and contract, slightly changing its size and temperature. When Betelgeuse's surface expands, the temperature drops even further, and its light becomes even redder. When it contracts, it heats up and may appear a bit brighter and less red. This behavior is one of the reasons why Betelgeuse fascinates astronomers so much. But how do we know so precisely the temperature of such a distant star? Scientists use spectroscopy, a technique that analyzes the light coming from the star. Each chemical element emits and absorbs light at specific wavelengths, and these signals act like a barcode that reveals not only the composition, but also the surface temperature of the star. Thus, by studying the light from Betelgeuse, astronomers can determine that its temperature is among the lowest of visible stars, perfectly aligning with its reddish appearance and classifying it as a red supergiant in the midst of stellar transformation. Why does Betelgeuse shine so brightly in our night sky? At first glance, it stands out in the constellation of Orion as one of the brightest stars, but the answer goes far beyond its relative proximity to Earth. Betelgeuse is a red supergiant, and its brightness is the result of a combination of its colossal size and its unstable nature. If we compared Betelgeuse to a giant light bulb, it would be like placing a flashlight in front of a stadium lamp. The difference in light is staggering. Although its surface temperature is lower than that of the Sun, its immense volume allows it to emit a much greater amount of energy. But just how bright is Betelgeuse? Its luminosity is about 100,000 times greater than that of the Sun. Imagine gathering 100,000 suns in a single point. That comes close to the amount of light Betelgeuse emits. However, its apparent brightness from Earth is not constant. It varies due to the star's internal cycles and the layers of dust that occasionally envelop it. This variability means that sometimes Betelgeuse is the 10th brightest star in the sky, while at other times it drops several positions in the ranking of nightlights. The reason behind this extraordinary luminosity lies in its structure. Betelgeuse has exhausted the hydrogen in its core, so it fuses heavier elements in a kind of expanding cosmic furnace. In doing so, its outer layers inflate, and although the surface temperature decreases, the total surface area of the star multiplies millions of times compared to that of the Sun. Thus, it emits a colossal amount of light, distributed in all directions, traveling through space until it reaches our eyes. It's as if the star is breathing, expanding and contracting, modulating its brightness like the volume of a song on the radio. Could Betelgeuse shine even brighter in the future? The answer is yes, but only for a brief and spectacular moment. When it explodes as a supernova, its luminosity will increase so much that it could be visible even during the day from Earth. Until then, its brightness continues to fascinate astronomers and curious minds, not only for its intensity, but also for its changing and mysterious nature. Betelgeuse is not just a light in the sky. It is a living reminder of the enormous energy and dynamism that stars hide within. Determining the exact distance of Betelgeuse from Earth has been one of the most fascinating challenges for astronomers. Why is it so complicated to measure the distance to a star that shines so brightly in the sky? Although Betelgeuse seems within our reach due to its great luminosity, it is actually hundreds of light years away from us, and measuring that vast separation requires a combination of precision and scientific creativity. One of the main techniques used to calculate the distance is stellar parallax. What does this method involve? Imagine extending your arm and alternating the eye with which you look at your thumb. You will notice that your thumb seems to move against the background. Similarly, astronomers observe the apparent change in the position of Betelgeuse by viewing it from different points in Earth's orbit around the Sun. However, since Betelgeuse is so far away, that apparent movement is extremely small, barely fractions of a degree. For this reason, for a long time, estimates of its distance varied considerably. To improve accuracy, observations made by satellites like Hipparcos and Gaia have been used, allowing for refined calculations. But even with the most advanced technology, challenges remain. Betelgeuse is a giant star with an extensive and unstable atmosphere, complicating the determination of its exact center and therefore the measurement of its parallax. Additionally, its variable brightness and the presence of material ejected into the surrounding space can interfere with measurements. These factors have caused the figures to change over the years. So, how far away is Betelgeuse really? The most accepted current estimates place it at about 640 light-years from Earth. This means that the light we see today left Betelgeuse during the 15th century, at the height of exploration and discovery on Earth. Despite the advancements, there is still a small margin of error due to the unique characteristics of the star. However, what is clear is that, although it may seem close and familiar in the night sky, Betelgeuse is a colossus situated at an impressive distance, reminding us of how vast our universe is and the ingenious methods that science uses to measure it. Have you ever wondered why Betelgeuse doesn't always shine the same? While many people think of stars as fixed and unchanging lights in the sky, Betelgeuse is famous for the opposite. Its brightness varies significantly over time. This characteristic has intrigued astronomers for centuries, and in fact, is one of the reasons why Betelgeuse is so studied. But what causes these changes in its brightness? The key lies in its nature as a red supergiant star, and in the internal processes occurring within it. Betelgeuse is what astronomers call a semi-regular variable star. This means that its brightness increases and decreases in a more or less predictable manner, but not in a perfectly constant way. Sometimes, its light can be almost as intense as that of Rigel, another bright star in the constellation of Orion, and at other times it can appear much weaker. This phenomenon is primarily due to stellar pulsations. Betelgeuse expands and contracts as if it were slowly breathing, altering its size and surface temperature. When the star expands, its temperature drops and its brightness decreases. When it contracts, it heats up and shines more brightly. But pulsations are not the only cause of its variability. Being a massive star in the final stages of its life, Betelgeuse is losing material from its outer layers, expelling large amounts of gas and dust into space. This material can form clouds that, depending on their density and position, block part of the star's light before it reaches us. It's as if, from time to time, a cosmic fog passes in front of Betelgeuse, making it appear dimmer from Earth. Does this mean that Betelgeuse is about to explode? Not necessarily, but each change in its brightness is like another clue in the great mystery of its final fate. Astronomers have studied and recorded these variations for a long time, using both naked eye observations and sophisticated modern instruments. Thanks to these studies, it is known that Betelgeuse can change its brightness in cycles that last from several months to a few years. These cycles are not perfectly regular, making it a real challenge to predict the exact behavior of the star. The variability of Betelgeuse makes it a natural laboratory for studying stellar evolution processes and better understanding how the most massive stars in the universe live and die. In summary, every flicker of Betelgeuse is an invitation to look at the sky and wonder what other secrets our galaxy holds. What would happen if, suddenly, one of the brightest stars in the night sky began to noticeably dim? This is exactly what happened with Betelgeuse between the end of 2019 and the beginning of 2020. Many observers, both amateur and professional, noticed that its brightness was fading, becoming as weak as had never been recorded in modern history. This decrease in brightness, known as the Great Dimming, unleashed a flurry of theories and speculations throughout the scientific community. Was Betelgeuse about to explode as a supernova? Or was it a completely different phenomenon? To understand this mystery, it is important to know how Betelgeuse typically behaves. As a variable star, its luminosity naturally fluctuates in cycles of several hundred days. However, the magnitude of the recent dimming was unusual, reaching only a third of its typical brightness. This anomaly led astronomers to seek explanations beyond the usual changes. One of the first hypotheses suggested that Betelgeuse might be living its last moments before a cataclysmic explosion. But is it really that simple? The key to the enigma seemed to lie in the surface and environment of the star. Some research pointed to the sudden formation of enormous clouds of dust, generated by the expulsion of material from the outer layers of Betelgeuse. Imagine a gigantic cloud of ash covering a bright lamp. Although the lamp is still on, its light dims due to the obstruction. Thus, it was proposed that the cold dust, expelled by intense stellar winds, blocked part of the visible light from Earth. Other theories suggest that large cold spots on the surface of the star, similar to sunspots but much more extensive, could have contributed to this phenomenon by temporarily lowering the temperature and brightness in certain regions. Although Betelgeuse's brightness gradually returned to normal months later, the astronomical community remains vigilant. This episode has served as a reminder of how little we know about the final behavior of supergiant stars. Could this dimming happen again? Or was it merely a prelude to even more dramatic events? For now, Betelgeuse continues to shine in the sky, but its recent history reminds us that, in the universe, nothing is truly predictable. What do a distant star and a comedy movie have in common? Betelgeuse, besides being an astronomical gem, has left a surprising mark on popular culture. Did you know that its name inspired the title of the famous 1988 movie Betelgeuse? Although the pronunciation changed and the plot has nothing to do with the cosmos, the mere fact that a star has given its name to such a peculiar character shows how the universe impacts human creativity. But Betelgeuse is not limited to cinema. In literature, it has fascinated science fiction writers for decades. Douglas Adams, for example, mentions Betelgeuse in The Hitchhiker's Guide to the Galaxy as the home of one of his most charismatic characters. Even Isaac Asimov included it in his stories, turning it into a starting point for imaginary civilizations and interstellar journeys. What makes this star spark so much inspiration? Perhaps it's its enigmatic name, or its prominent position in the sky, a kind of red beacon among the constellations, inviting dreams of other realities. Have you ever wondered if ancient civilizations also gave it a special place in their stories? Betelgeuse appears in mythologies and legends around the world. For the Arabs, its original name referred to the hand of the giant, while for indigenous peoples of America, it was a fundamental part of tales about the origin of the universe and celestial hunting. Thus, Betelgeuse has not only shone in the sky, but also in the collective imagination of humanity. And in the modern era, Betelgeuse is a recurring protagonist in video games, comics, and animated series. From epic stories where an event in the star triggers galactic adventures, to mentions in songs and references in geek culture, its name has become synonymous with mystery and wonder. Why does such a distant star manage to infiltrate so many artistic expressions? Perhaps because looking at Betelgeuse is, in some way, looking at our longing to explore the unknown and understand our place in the vast universe. What makes the atmosphere of Betelgeuse so fascinating for astronomers? Unlike the atmosphere of the Sun, which is relatively compact, that of Betelgeuse is extensive and chaotic, extending far beyond what one would expect for a star. If we could compare the atmosphere of Betelgeuse to an onion, we would find overlapping and diffuse layers of gas, some so unstable that they expand and contract unpredictably. Why does this happen? Because the gravity of Betelgeuse, although powerful, does not firmly hold the outer layers, allowing material to shift and escape easily. One of the most surprising features of Betelgeuse's atmosphere is its size. It extends up to dozens of times the diameter of the star itself. This means that if Betelgeuse were to replace the Sun at the center of the solar system, its atmosphere could reach beyond the orbit of Jupiter. But how do we know this if we can't travel there? Astronomers use techniques like spectroscopy, which allows them to analyze the light emitted by the star and discover the composition and structure of its gaseous layers. Thanks to these methods, it has been detected that the atmosphere contains complex molecules, such as carbon monoxide and water, in addition to interstellar dust. Is Betelgeuse's atmosphere homogeneous and stable? Quite the opposite. It is turbulent, with enormous bubbles of hot gas rising and falling on its surface, resembling gigantic globs in a lava lamp. These convective movements cause changes in brightness and ejections of material into space, which can sometimes make the star appear dimmer from Earth. Furthermore, the atmosphere is neither spherical nor regular. Recent observations show that Betelgeuse has a somewhat distorted shape, with regions where gas accumulates in huge irregular clouds, or even breaks away, forming arcs and filaments around it. Why is it important to study the atmosphere of Betelgeuse? Because here lie the keys to understanding how massive stars lose mass and enrich the interstellar medium. Each episode of atmospheric instability, each bubble that rises, is a clue about the processes that precede the death of these giants. In short, the atmosphere of Betelgeuse is a natural laboratory to observe in real time the final fate of the largest stars in the universe. What makes a massive star like Betelgeuse change shape and lose part of itself into space? The answer lies in a fascinating phenomenon known as stellar wind. Contrary to what we might imagine, stars are not static objects. In fact, Betelgeuse is constantly releasing material into the surrounding space. This continuous flow of gas and dust, driven by the intense radiation and internal dynamics of the star, is known as stellar wind. If we think of Betelgeuse as a gigantic cosmic bonfire, the stellar wind would be like the smoke and sparks that break off and scatter in all directions. But how powerful is this stellar wind? In the case of Betelgeuse, the amount of mass it loses is truly astonishing. Each year, this red supergiant expels into space an amount of material equivalent to the mass of our own Sun over the course of 100,000 years. This mass loss occurs because the energy generated in the star's inner layers travels to the surface, pushing the outer layers with such force that they overcome the star's own gravity and escape into space. It's as if Betelgeuse is constantly shedding its outer layer, throwing enormous amounts of gas, dust, and particles into the interstellar void. And why is this mass loss process so important? The reason is that it not only affects the star's final fate, but also enriches the interstellar medium with heavy elements. The material expelled by Betelgeuse contains carbon, oxygen, and other essential elements for the formation of new stars and planets. Thus, the stellar wind is not only a symptom of Betelgeuse's aging, but also a kind of cosmic legacy, sowing the necessary ingredients for the creation of future planetary systems. Finally, the interaction between the stellar winds of Betelgeuse and the interstellar material generates complex structures and nebulae around it. Astronomers study these envelopes of gas and dust to better understand how massive stars contribute to the evolution of the galaxy. Could the force of Betelgeuse's stellar wind influence its own death as a supernova? Scientists believe so. The amount of mass the star manages to lose before exploding can determine the type of explosion and the remnant it will leave behind. Thus, the stellar wind and mass loss are not just curious details. but key pieces in the final destiny of one of the most impressive stars in the sky. What happens when a star as massive and active as Betelgeuse begins to lose part of its material into space? Surrounding this red supergiant is an impressive nebula formed from the very material that the star has expelled over thousands of years. This cloud, composed mainly of gas and dust, is like a cosmic fingerprint that reveals the history of the intense internal processes that Betelgeuse undergoes. But why does a star begin to envelop itself in its own nebulosity? From time to time, Betelgeuse releases enormous amounts of mass due to its powerful stellar winds, which carry elements formed inside the star out into space. The result is an extensive and diffuse envelope, much larger than the star itself, that can extend to distances equivalent to several times the diameter of our solar system. To give you an idea, if Betelgeuse were at the center of the solar system, its nebula could reach beyond the orbit of Jupiter. This expelled material is not just gas, but also interstellar dust, solid particles that help form new stars and planets in the future. Why is it so difficult to directly observe this nebulosity? The dust and gas surrounding Betelgeuse tend to scatter and absorb visible light, hiding part of the star and its immediate surroundings. It's like trying to see a lit flashlight through dense fog. The light blurs, and everything becomes hazy. However, astronomers have learned to look in other wavelengths, such as infrared, to penetrate that veil and study the structure of the nebula. Thus, they have discovered arcs and filaments that reveal how the material has been expelled in different episodes, as if the star has been breathing irregularly over time. This nebula is not just a visual spectacle, but also a clue about the future of Betelgeuse. By analyzing the composition and distribution of this material, scientists can reconstruct the rate at which the star loses mass and anticipate its final evolution. Furthermore, the interaction between the stellar wind and the interstellar medium generates shock waves that heat the gas and produce emissions detectable from Earth. Ultimately, the nebulosity surrounding Betelgeuse is a time capsule, a record of the last breaths of a colossal star that is nearing the end of its life cycle in the universe. Have you ever wondered if the stars remain fixed in the sky, like nails in a gigantic vault? The reality is that, although they appear motionless from Earth, all stars move through space, and Betelgeuse is no exception. But how fast is this red supergiant moving, and where is it headed? The truth is that Betelgeuse travels through the galaxy at a surprising speed relative to our Sun, on a path that astronomers call proper motion. The proper motion of Betelgeuse is the apparent displacement of the star in the sky, caused by its actual movement through space compared to the background stars. To understand it, imagine you're driving a car down the road and see how the nearby trees seem to move faster than the distant mountains. Similarly, Betelgeuse, although it is hundreds of light years away from us, moves enough that, over the centuries, its position changes significantly. Its proper motion speed is about 31 kilometers per second relative to the Sun, which is almost 100 times faster than a commercial airplane. Where is Betelgeuse headed? Studies show that the star is moving in a northeast direction in the sky, gradually distancing itself from the constellation Orion as we see it today. If we could observe the sky over tens of thousands of years, we would notice that the shape of the constellation would change drastically, because Betelgeuse will have left its characteristic position. This stellar journey is not a coincidence. Betelgeuse, like many other massive stars, moves through the Milky Way following paths dictated by gravitational forces and ancient encounters with other stars and clouds of gas. Why is it important to know the proper motion of Betelgeuse? Besides giving us clues about its origin and history, this motion leaves a mark on its surroundings. As it moves forward, Betelgeuse interacts with the interstellar material, generating a shockwave, a kind of cosmic wave, similar to what a boat produces while sailing through water. This phenomenon reveals details about the star's speed and the characteristics of the interstellar medium. Thus, the movement of Betelgeuse is not just an astronomical curiosity. It is a window into the dynamics of our galaxy and the fate of one of the most fascinating stars in the night sky. How do we know that Betelgeuse has captivated humanity for centuries? The answer is recorded in records that date back to ancient civilizations. The early astronomers of Babylon, over 2,500 years ago, already mentioned a bright reddish star in the constellation of Orion. For them, Betelgeuse was not just a light in the sky, but a marker of the passage of the seasons and a portent of significant events. On clay tablets, the Babylonians noted observations about its brightness and position, showing that its importance was not minor. In ancient Greece, Betelgeuse was part of the myths related to Orion, the giant hunter. But how did ancient peoples know that this star was different? The key lies in its color and luminosity. Unlike most stars that appear white or bluish, the reddish hue of Betelgeuse made it unmistakable. Medieval Arab astronomers also identified it and gave it proper names, such as Yad al-Jawza, which means the hand of Orion. Their records, long before the era of telescopes, already suggested that they were observing a peculiar star. During the Middle Ages and the Renaissance, Betelgeuse continued to be a nighttime reference. In Chinese and Japanese chronicles, descriptions of variations in its brightness appear, indicating that even then, astronomers perceived its apparent changes. How could they notice these differences without modern instruments? The answer is simple. By observing night after night, the ancients noted when Betelgeuse shone more brightly or seemed to fade slightly, as if it were breathing alongside the cosmos. This quality set it apart from other more constant stars and contributed to its mysticism. With the invention of the telescope in the 17th century, Betelgeuse became an object of study for great European astronomers. Galileo and his contemporaries catalogued and analyzed it, intrigued by its color and apparent size. Later, in the 19th century, William Herschel and other pioneers of modern astronomy established that Betelgeuse was not an ordinary star, but a red supergiant. Thus, the historical records of multiple cultures and eras form a fascinating tapestry. Betelgeuse has been observed, admired, and studied over millennia, reflecting humanity's eternal curiosity about the universe. How is it possible that, being hundreds of light years away, we can study the secrets of a star as gigantic as Betelgeuse? The advancement of technology in astronomy has allowed scientists today to observe details that were once unthinkable. Thanks to state-of-the-art telescopes, both on Earth and in space, a window has opened to the modern observation of Betelgeuse. Instruments like the Hubble Space Telescope, the VLT in Chile, and the ALMA radio telescope have revolutionized the way we analyze this star, enabling us to observe its surface, measure its changes, and study its environment in different wavelengths. Did you know that we have managed to obtain direct images of the surface of Betelgeuse? This is something that, until recently, was only possible in the case of the Sun. Using techniques like interferometry, astronomers can combine the light from several telescopes to create a virtual super telescope, capable of distinguishing tiny details on the star's surface. Thus, enormous spots and gas bubbles have been detected, some the size of Mars's orbit, emerging and disappearing in cycles that last only months. These observations have been key to understanding the internal dynamics and mass loss of Betelgeuse. But how do we measure the distance and movement of such a distant and variable star? Scientists resort to modern techniques like high-precision astrometry, using satellites like Gaia, which map our galaxy with astonishing accuracy. Additionally, spectroscopic analysis allows us to identify the speed at which Betelgeuse is moving away from or towards us, as well as the elements present in its atmosphere. Each observation adds a piece to the puzzle of the life and eventual fate of this red supergiant. Continuous monitoring, day and night, of Betelgeuse is possible thanks to international networks of automated telescopes that watch its brightness, temperature, and activity. This has allowed astronomers to capture the mysterious drops in luminosity and react in real time, initiating global observation campaigns. In the modern era, data is shared within hours, so any detected anomaly can be studied from different points on the planet, taking advantage of international scientific collaboration. Thus, Betelgeuse has become a true stellar laboratory, demonstrating how technology and global cooperation bring us closer to the great mysteries of the cosmos. Is it possible for a star to reveal hidden secrets if we observe it with different eyes? Although at first glance Betelgeuse appears to us as a bright reddish spot in the night sky, the reality is much more complex and fascinating. Stars, like a diamond under different beams of light, show different aspects depending on the wavelength with which we observe them. Betelgeuse is no exception. By examining it in visible, infrared, ultraviolet, and even radio light, astronomers unveil layers and phenomena that would be impossible to notice with our own eyes. In the visible spectrum, Betelgeuse stands out for its intense reddish color. This hue comes from its low surface temperature compared to hotter and bluer stars. However, when we look beyond the visible range and enter the infrared, we discover an even more surprising Betelgeuse. Infrared allows scientists to see through the stellar dust surrounding the star, revealing enormous gas envelopes and extended structures formed by the material that Betelgeuse has been expelling throughout its life. It's as if the star were wrapped in a veil that can only be lifted with instruments sensitive to these wavelengths. And what happens if we observe Betelgeuse in ultraviolet? In this range, the star shows intense activity in its outer layers. Ultraviolet reveals regions of high energy and allows us to detect dynamic processes, such as shock waves produced by the instability of its atmosphere. Furthermore, thanks to observations in X-rays and radio, we can study the hottest areas and emissions resulting from the interaction between the stellar wind and the surrounding material. Each window of the electromagnetic spectrum provides a unique piece to the puzzle, allowing astronomers to understand the internal and external physics of this red supergiant. Why is it so important to look at Betelgeuse in all these wavelengths? Because each one reveals different aspects of its structure and evolution. The visible tells us about its surface, the infrared about its dusty environment, the ultraviolet and X-rays about its turbulent atmosphere and energetic processes. Observing Betelgeuse across the entire spectrum is like reading a book with pages invisible to the naked eye, and only by turning each page with the right tool can we comprehend the true magnitude and complexity of this fascinating star. Thus, science continues to unveil the mysteries of Betelgeuse, using light as the key that opens doors to new discoveries in the universe. How is it possible to know what happens in the heart of a star as distant as Betelgeuse? Although we cannot travel to its core, science has devised ingenious methods to decipher its internal structure. Astronomers use physical models based on the way energy waves travel through the star, a technique similar to how geologists study the Earth's interior by analyzing earthquakes. But what do these models reveal about the innards of Betelgeuse? At the center of Betelgeuse lies its core, a region where temperatures and pressures reach unimaginable figures. There, atoms collide violently and fuse, releasing enormous amounts of energy through the process known as nuclear fusion. Currently, Betelgeuse has exhausted much of its central hydrogen and has begun to fuse helium, marking an advanced stage of its life. What does this mean? That its core is like the engine of a car on the verge of overheating. It consumes heavier fuels and produces new elements with each fusion cycle. Surrounding the core, there exists a series of concentric layers, each dedicated to fusing different elements. It's a bit like a giant onion, where each layer represents a new fuel: hydrogen, helium, carbon, oxygen, and even heavier elements. As the star depletes the resources of one layer, the next begins to fuse, generating distinct zones of high activity. This process creates a delicate balance between the outward pressure, caused by the energy of fusion, and the gravitational attraction trying to compress the star. But how do we really know that these layers exist? The key lies in observing the surface vibrations and analyzing the light emitted by Betelgeuse. These signals allow us to infer the internal movements and the composition of its layers, somewhat like listening to the echo inside a cave to deduce its size and shape. Additionally, studying the variability in the star's brightness provides clues about the internal dynamic processes, as pulsations and instabilities indicate changes in the fusion zones and the very structure of Betelgeuse. In summary, the internal structure of Betelgeuse is a marvel of stellar physics. A burning core where elements are forged, surrounded by layers in constant transformation and agitation. Understanding this complex interior not only allows us to know the fate of Betelgeuse, but also the life cycle of massive stars and the chemical history of the universe. What other secrets might the depths of other red supergiants hold? That is a question that astronomy continues to explore with each new observation. What does it really mean for a star to pulse in space? Betelgeuse is famous for its stellar pulsations, a fascinating phenomenon that causes it to expand and contract rhythmically, as if it were breathing slowly. But why does this happen? The answer lies in the delicate balance between gravity and the internal pressure of the star. When the energy produced in the core pushes outward, the surface of Betelgeuse expands. Then gravity takes control and the star shrinks back down. This cycle repeats over and over, causing changes in the size and brightness of the star, noticeable even from Earth. These pulsations are not whimsical or random. They are due to complex physical processes inside Betelgeuse. Imagine a pot of boiling water. The heat from the bottom generates bubbles that rise and agitate the surface. Similarly, the inner layers of Betelgeuse transport energy outward, generating pressure waves that travel through the star and produce these pulsations. Each cycle can last from several months to over a year, depending on the internal conditions of the star. This variability is what makes it a semi-regular variable star, a type of celestial object that intrigues astronomers due to its difficult-to-predict behavior patterns. How does this affect astronomers? The stellar pulsations of Betelgeuse are a crucial clue for understanding its internal structure and evolution. By analyzing the changes in brightness and spectrum of the star, scientists can deduce details about the layers and processes occurring within, similar to how seismologists study the Earth's interior from earthquakes. This stellar heartbeat is, in a way, a coded message that the star sends to the universe, and astronomers are dedicated to deciphering it. Moreover, these pulsations are closely related to the material that Betelgeuse expels into space. As the star expands, some of its outer layers may shed and form clouds of gas and dust around it. This process contributes to the richness of elements in the cosmos, as red supergiants like Betelgeuse are factories for new chemical elements. Thus, the mere fact that a star pulses has profound consequences for life and the evolution of matter in the universe. Will we ever be able to predict exactly how and when Betelgeuse will change due to its pulsations? For now, each cycle of expansion and contraction offers us a new opportunity to peek into the heart of one of the most colossal and mysterious stars in the sky. Have you ever wondered if Betelgeuse is the only impressive red supergiant in the sky? The truth is, it's not alone. There are other stars that have also reached colossal sizes and advanced evolutionary phases, and one of the most famous is Antares, located in the constellation of Scorpius. But how are these titans of the sky alike and different? Antares and Betelgeuse share that characteristic reddish color, a result of their low surface temperatures, and both are red supergiants in the final stages of their lives. However, although they may seem like distant twins at first glance, each has its own stellar personality. When we compare their sizes, Betelgeuse and Antares may seem monstrously large, but Betelgeuse takes the crown in terms of apparent volume. If Betelgeuse were in the place of the Sun, its radius would extend beyond the orbit of Mars, while Antares, although also enormous, would probably only reach close to the orbit of Mars, but not exceed it. And what about mass? Betelgeuse is somewhat less massive than Antares, but both exceed the Sun by dozens of times in this aspect. This shows that size and mass do not always go hand in hand in the stellar world. A star can be larger in volume, but not necessarily heavier. Did you know that even among red supergiants there are differences in their life pace? Betelgeuse, for example, is known for its variability, changing brightness perceptibly over months or years. Antares also varies in luminosity, but in a less noticeable way and with less dramatic cycles. Additionally, The distance at which they are from Earth marks another important difference. Betelgeuse is about 640 light-years away, while Antares is located about 600. Although both seem like neighbors in the vast galactic neighborhood, distance directly influences how we perceive them from our planet. We cannot forget that there are other even more extreme red supergiants, such as VY Canis Majoris or UY Scuti, which can be several times larger than Betelgeuse. However, these are not as bright to the naked eye or as famous because they are much farther away or are partially hidden by clouds of interstellar dust. Betelgeuse and Antares, on the other hand, stand out for being easily visible and part of recognizable constellations, making them true celestial celebrities. Comparisons between these stars not only reveal the diversity of the universe, but also remind us how fleeting and extraordinary the fate of a massive star can be. In the end, each red supergiant is a different story of birth, growth, and stellar death. Some will be remembered for their size, others for their luminosity, or even for the spectacularity of their potential explosion as a supernova. Science is constantly discovering new peculiarities in each one, but they all share an astonishing reality. They are authentic cosmic laboratories, where the elements that will eventually give rise to new stars and planets are forged. What will be the next great surprise that these giants of the cosmos have in store for us? Can a star as distant as Betelgeuse influence life on Earth? At first glance, it might seem impossible, but the relationship between stars and existence itself on our planet is much deeper than we imagine. Our history, from the origin of life to the present day, is intimately intertwined with the great stars of the universe, and Betelgeuse is one of the best examples to understand this cosmic bond. One of the most fascinating aspects is that the essential elements for life, such as carbon, oxygen, and iron, were formed in the interiors of massive stars like Betelgeuse. When these stars exhaust their fuel and explode as supernovae, they scatter these elements across space, enriching the clouds of gas and dust from which new stars and planets arise. Without these processes, Earth, the oceans, living beings, and even our own bodies simply would not exist. Can it be said then that we are stardust? Science answers with a resounding yes. Now, has Betelgeuse had a direct effect on life on Earth? So far, the influence has been indirect, through the cycle of stellar creation and destruction that allows for the formation of habitable planets. However, the question that intrigues many is, what will happen when Betelgeuse explodes as a supernova? Could that explosion affect life on Earth? Fortunately, the distance at which it is located, about 640 light-years away, protects us from the most destructive effects like lethal radiation or powerful cosmic rays. To put it in perspective, it would be like being safe on a distant beach while a thunderstorm occurs on the other side of the ocean. Despite that safety, the explosion of Betelgeuse as a supernova would be an unprecedented spectacle for humanity. For several weeks, the light could rival that of a full moon, allowing the night to be illuminated without the need for flashlights. Fossil and geological records show that, in previous instances, explosions of closer supernovae have left traces on Earth, such as the presence of certain isotopes in ocean sediments. But in the case of Betelgeuse, scientists agree that there will be no direct negative impact. Rather, we will be privileged witnesses to a phenomenon that on human timescales occurs only once every many generations. Ultimately, Betelgeuse reminds us that life on Earth is not an isolated phenomenon, but the result of a chain of cosmic events that began long before the formation of our own sun. Looking at Betelgeuse is looking into our past, and also into the material future of life on other worlds. Thus, although Betelgeuse may not alter our day-to-day lives, its history and fate connect us with the eternal cycle of matter and energy in the universe. When we think of cosmic explosions, few images are as striking as that of a supernova. Why are astronomers so focused on Betelgeuse? waiting for it to become one of them. The reason is simple. Betelgeuse is a massive star that has exhausted much of its fuel and is in the final stage of its life. But what does that really mean? Stars like Betelgeuse, after millions of years fusing hydrogen and helium in their core, reach a critical point where the energy released is no longer enough to support their colossal weight. It is then that the star's fate is sealed and the countdown to the supernova begins, although no one knows exactly when it will happen. Many wonder if we are about to witness that event in real time. Could it happen tomorrow? Or maybe in 100,000 years? The truth is that on the scale of human life, it is impossible to predict it accurately. The latest calculations suggest that Betelgeuse could explode at any moment within the next 100,000 years. A tiny fraction in the history of the universe, but a gigantic interval for us. The uncertainty arises because although we understand well the theoretical processes that lead to a supernova, we still do not have a precise alarm that tells us when a star is about to blow. It's like watching a pot of boiling water without knowing when the lid will pop off. Are there signs that anticipate the final explosion? Scientists continuously monitor changes in the brightness, temperature, and composition of Betelgeuse looking for clues. However, despite all the available technology, the transition from a red supergiant to a supernova is so rapid and so complex that the warnings can be subtle or even non-existent until the last moment. This makes Betelgeuse a kind of astronomical time bomb. We know it will explode, but we don't know when. And that wait, filled with mystery and anticipation, is a reminder of how little we still understand about the life cycle of the most massive stars. The global interest in Betelgeuse is not just scientific, it is also human. The possibility of witnessing a supernova visible to the naked eye connects us with generations of skywatchers who looked at this star wondering about its fate. What would we feel if, suddenly, one of the brightest stars in the sky became a beacon as bright as the full moon? For now, we can only wait and continue observing with patience and fascination, knowing that, at any moment, the universe could gift us one of its grandest spectacles. What signs announce the imminent death of a star as colossal as Betelgeuse? Astronomers have been monitoring this stellar titan for decades, searching for clues that indicate it is about to explode as a supernova. But how can such a colossal and sudden event be predicted? The key lies in observing certain phenomena that precede the final catastrophe, as if the star were emitting a last sigh before its grand cosmic finale. One of the most sought-after signs is the increase in the intensity and frequency of the star's pulsations. Betelgeuse, like other red supergiants, experiences changes in its brightness and size due to internal processes. However, in the final phase of its life, these pulsations can become much more irregular and violent. It's as if the heart of the star is beating out of control, reflecting the instability of its core. Astronomers monitor these changes using telescopes from around the world, on the lookout for any unusual patterns that indicate the star is near collapse. Another crucial clue is the detection of neutrinos. Neutrinos are nearly massless subatomic particles that can easily pass through matter and are produced in enormous quantities when the core of a massive star begins to collapse. If scientists detect a sudden increase in neutrinos coming from the direction of Betelgeuse, they will know that the supernova process has begun, even before seeing the burst of light. This method is so effective that, if the explosion were to occur, the neutrinos would reach Earth several hours before the visible light. Furthermore, studying the chemical composition of Betelgeuse's atmosphere can reveal significant changes. When a star is about to explode, heavy elements begin to appear on its surface, expelled by intense internal shock waves. If astronomers detect a sudden increase in these elements, such as nickel or iron, they may suspect that the star is in its terminal phase. It's as if the star begins to show the scars of its most violent internal processes just before collapse. Finally, attention is paid to the emission of X-rays and gamma rays, which can dramatically increase in the stages leading up to the supernova. These high-energy flashes indicate that the star's core is experiencing extreme reactions, a direct prelude to the explosion. Thus, the combination of variations in brightness, neutrino signals, chemical changes, and energetic emissions forms a kind of early warning that allows astronomers to anticipate one of the most striking spectacles in the universe. Will it be possible that we soon witness the death of Betelgeuse? No one knows for sure, but the watch continues. What happens when a star like Betelgeuse reaches the end of its life? The answer is as spectacular as it is terrifying. It becomes a supernova. But how does this phenomenon actually occur? When Betelgeuse exhausts all its nuclear fuel, it will no longer be able to maintain the balance between the outward pressure generated by nuclear reactions in its core and the gravity that tries to collapse it inward. Without that energy support, the core of the star will begin to compress rapidly under its own weight. This compression is so intense that, within seconds, the inner layers collapse and then violently rebound, generating a shockwave of unimaginable energy. That shockwave travels through the outer layers of Betelgeuse, expelling stellar material into space at speeds of thousands of kilometers per second. It's as if the star explodes from the inside, launching into the cosmos everything that isn't bound to its core. In that moment, for a few days or weeks, the supernova can shine as brightly as an entire galaxy. Why such brightness? The explanation lies in the release of enormous amounts of energy and the formation of heavy elements, like gold and uranium, which can only be created under such extreme conditions. The collapse and explosion trigger nuclear reactions that produce these elements, enriching the interstellar space and sowing the ingredients for future generations of stars and planets. But what happens to the core of Betelgeuse after the explosion? If the remaining mass is sufficient, the core compresses into a neutron star, an incredibly dense object, where a teaspoon of matter would weigh millions of tons. If the mass is even greater, the final fate would be the formation of a black hole, a point in space where gravity is so intense that nothing can escape. This fate depends on the precise amount of material left after the explosion, and it is one of the great mysteries that astronomers hope to solve by observing supernovas in real time. Could the explosion of Betelgeuse affect life on Earth? Despite the magnitude of the event, Betelgeuse is far enough away that the radiation and expelled particles do not pose a direct threat to us. However, the cosmic spectacle would be stunning. The supernova could be visible even during the day and remain bright for several weeks. Ultimately, the expelled material will expand and form a nebula, a cloud of gas and dust that over time could give rise to new stars. Thus, the death of Betelgeuse would be the beginning of new cycles of life in the universe, reminding us that, in the cosmos, all destruction is also an opportunity to create something new. What would happen if a star, located over 600 light-years away from us, exploded and became one of the most stunning displays ever seen in the sky? The red supergiant Betelgeuse is destined to star in that event, a supernova visible to the naked eye from Earth. But how would this phenomenon actually look from our planet? Would it be as spectacular as we imagine, or just a fleeting glow in the celestial vault? When Betelgeuse explodes, its brightness will increase so intensely that for a brief period, it will outshine almost all the stars in the firmament. It is estimated that during the first few days, it could be as bright as a full moon, even casting shadows at night. No telescope would be needed to observe it. Anyone, from anywhere in the world where Orion is visible, could look up and witness the birth of a supernova. Can you imagine seeing a new star suddenly appear, eclipsing the others and challenging the routine of the night sky? That would be the stunning visual impact of this event. The duration of this spectacle is also fascinating. The Betelgeuse supernova would be visible to the naked eye for several weeks or even months, depending on atmospheric conditions and the position of the constellation. Gradually, its brightness would diminish, but it would still be observable with binoculars or small telescopes for years. It's as if the sky is gifting us a temporary cosmic beacon, a sign that the universe is alive and in constant transformation. Even as the intensity decreases, the mark it leaves on the collective memory will be indelible. And what about the colors? The explosion of Betelgeuse could display hues ranging from bright white to orange-red, depending on the stage of the supernova and the elements expelled into space. The most attentive observers might notice subtle changes in color during the different phases, something rarely witnessed in the history of humanity. Undoubtedly, the Betelgeuse supernova would not only be an astronomical event, but also a cultural and visual phenomenon, capable of astonishing all those fortunate enough to witness it. Are we ready to see how a star dies with one last dazzling act of light? What would happen if one of the brightest and closest stars exploded as a supernova? Could such an explosion somehow affect our solar system? These questions generate as much fascination as they do unease. The explosion of a red supergiant like Betelgeuse, while spectacular in the sky, often fuels myths and fears about potential disasters for Earth. But what does science say about it? First of all, it is essential to understand the distance at which Betelgeuse is located. It is estimated to be about 640 light-years away from us. In cosmic terms, that is relatively close, but enough that the lethal radiation from a supernova does not pose a direct risk to our planet. To put it in perspective, a supernova would have to occur within about 50 light-years to cause serious damage to Earth's biosphere, such as the destruction of the ozone layer or dangerous increases in radiation. Fortunately, Betelgeuse is much farther away. So, will there be any noticeable effects beyond the incredible visual spectacle? Yes, but they are mild compared to the drama of movies. The main consequence would be an increase in the arrival of cosmic rays, high-energy particles that would travel through space after the explosion. However, Earth's magnetic field and atmosphere effectively protect living beings from this type of radiation. Perhaps scientific instruments will detect a slight increase in particles, but for the average human, life would continue as usual. Another intriguing question is whether the shockwave from the supernova could affect the planets or even destabilize orbits within the solar system. The answer is no. Although the explosion of Betelgeuse will release a tremendous amount of energy and material into space, by the time it reaches the distance of our solar system, that energy will have dispersed so much that its effect will be practically null. It's like someone lighting a firecracker on the other side of the city. The light may be visible, but neither the heat nor the sound would reach you. However, what could be impacted is the unique opportunity for science. The explosion of Betelgeuse would allow astronomers to study in real time the birth of a nearby supernova, better understand the physics of these events, and analyze the interaction of the shock wave with the interstellar medium. Any potential consequence for Earth will be more intellectual, an avalanche of data, discoveries, and new questions about our place in the cosmos. So, when Betelgeuse explodes, we will be able to admire the spectacle knowing that, beyond a night illuminated like never before, our solar system will remain safe and sound. What happens when a colossal star like Betelgeuse reaches the end of its life? Does it slowly fade away, or does it leave an indelible mark on the cosmos? The answer is far more spectacular than we could imagine. When Betelgeuse explodes as a supernova, its core will undergo a gravitational collapse so intense that it will trigger a chain reaction of titanic forces. But what will remain after such a cataclysm? To understand this, let's think of the life of a star like Betelgeuse as that of a giant that, after burning for millions of years, finally collapses under its own weight. At that critical moment, the outer layers of the star will be expelled into space at incredible speeds, forming a cloud of gas and dust known as a supernova remnant. This remnant is not only a visual spectacle, but also a true cosmic factory of heavy elements, such as gold and uranium, that will travel through space and someday could become part of new planetary systems. But what happens in the very heart of Betelgeuse after the explosion? There, matter is compressed so much that protons and electrons fuse, giving rise to neutrons. The most likely outcome is the birth of a neutron star, an object so dense that a teaspoon of its material would weigh millions of tons on Earth. This core, the size of a city, will spin rapidly and could emit powerful beams of radiation, becoming a pulsar visible from great distances. Is there a possibility that the remnant could be even more extreme? Only if Betelgeuse were much more massive than astronomers currently estimate. The collapse could be so intense that even neutrons would not withstand it, forming a black hole. However, current calculations suggest that Betelgeuse does not have enough mass for this fate, so the neutron star is the most probable outcome. Thus, although Betelgeuse's life will end violently, its legacy will continue. The stellar remnant will be a testament to its existence, a neutron star spinning at impressive speeds, surrounded by a bright nebula that will carry the material of Betelgeuse to new generations of stars and planets. It is a reminder that in the universe, the end of a star can be the beginning of countless new stories. When we think about the elements that surround us, from the iron in a bicycle to the gold in a ring, few imagine that their origin is tied to gigantic stellar explosions. But how can a star like Betelgeuse play a crucial role in the creation of these heavy elements? The answer lies in the most extreme and fascinating processes of the universe, where the life and death of stars not only transform the cosmos, but also sow the fundamental ingredients of matter. Inside, Betelgeuse acts as a true nuclear laboratory. For most of its life, it fuses hydrogen into helium, releasing enormous amounts of energy. But as it exhausts its main fuel, the star begins to fuse helium into heavier elements like carbon and oxygen. Can this process continue indefinitely? No, there is a limit: iron. In the core of Betelgeuse, fusion continues to produce increasingly heavier elements, but when it reaches iron, the star faces a fundamental barrier. Fusing iron does not release energy. It consumes it, and this seals the star's fate. So, what happens when Betelgeuse reaches this critical point? When it can no longer sustain itself through fusion, its core collapses suddenly. In an instant, the star explodes in a supernova, releasing an almost unimaginable amount of energy. But the most interesting thing happens at that precise moment. The explosion of the supernova is so violent that it allows for the creation of even heavier elements than iron, such as gold, uranium, or platinum. In a matter of seconds, the explosion scatters these new elements across space, enriching the interstellar medium and sowing the seeds for the formation of new planets and, eventually, life. You might wonder, why is this process so important to us? The answer is that we are literally stardust. The atoms that make up our bodies and the world we inhabit were forged in ancient supernovae, in phenomena similar to the fate that awaits Betelgeuse. Without these cycles of stellar birth and death, the universe would be a simple place, formed almost exclusively of hydrogen and helium. Everything we consider valuable and essential, from the calcium in our bones to the copper in electrical wires, exists thanks to massive stars like Betelgeuse. Thus, Betelgeuse is not just a bright star in the night sky, but a cosmic factory that contributes to the complexity and chemical richness of the universe. Its explosive end will be the starting point for the creation of new worlds and generations of stars. Every time you look up at the sky and see that reddish point in the constellation Orion, remember that there, in silence, the raw material for future planets, life, and perhaps other civilizations is being forged. Civilizations that will one day also look to the stars wondering about their own origin. Why do astronomers consider Betelgeuse one of the most valuable stars for modern astrophysics? The answer lies in its unique nature and the advanced stage of its life. Betelgeuse is a red supergiant, one of the last phases in the life of massive stars. Studying it is like observing a cosmic laboratory in real time, where the fundamental processes of stellar evolution unfold before our eyes. Every change in its brightness, every variation in its size or composition, offers a crucial clue about how the largest stars in the universe are born, live, and die. Moreover, Betelgeuse serves as a benchmark for understanding the final fate of massive stars, those that end their days in violent explosions known as supernovae. How does a quiet star transform into one of the most destructive forces in the cosmos? Observing Betelgeuse allows us to anticipate the steps leading up to a supernova and comprehend the internal mechanisms that trigger this phenomenon. It's as if the star is showing us, step by step, the script of its own ending, allowing us to adjust and validate the theoretical models that scientists have built over decades. Another reason for its importance is that Betelgeuse acts as a testing ground for studying the physics of stellar atmospheres and mass loss. Red supergiants like Betelgeuse expel enormous amounts of material into space, enriching the interstellar medium with heavy elements. What role do these stars play in the chemistry of the universe? Without them, essential elements for life, such as oxygen or carbon, would not exist in our environment. Analyzing the material expelled by Betelgeuse helps us understand how these elements are distributed and how they influence the formation of new stars and planets. Finally, Betelgeuse is a key object for testing and improving astronomical observation techniques. Due to its size, relative proximity, and variability, it has been observed in virtually all wavelengths, from visible to infrared and radio. Every instrument, every observatory that points towards Betelgeuse contributes not only to unraveling the secrets of this star, but also to refining the tools that future generations of astronomers will use. Thus, Betelgeuse not only teaches us about its own nature, but also drives the advancement of all astrophysics. Did you know that Betelgeuse, that reddish star shining on the shoulder of Orion, has been a source of myths and legends for thousands of years? For many ancient cultures, the stars were not just points of light in the sky, but messages and omens that influenced daily life and the fate of peoples. Betelgeuse, due to its intense red color and prominent position, became the protagonist of stories that blend astronomy and magic, science and mystery. In ancient Greece, the constellation of Orion was linked to the figure of the giant hunter, and Betelgeuse represented his left shoulder. The Greeks viewed this star as a symbol of Orion's vigor and strength, while its reddish glow was associated with warnings of danger or with the blood shed in mythical hunts. Interestingly, on especially clear nights, when Betelgeuse shone with unusual intensity, the Greeks interpreted this phenomenon as an announcement of significant changes or even imminent disasters. But what did other cultures think about Betelgeuse? For the ancient Egyptians, the presence of this star in the sky played a fundamental role in the agricultural calendar. They associated Betelgeuse and other stars of Orion with Osiris, the god of resurrection and the afterlife. They believed that when Betelgeuse reached its highest point in the sky, the Nile was preparing to flood the lands, bringing prosperity and fertility. Thus, the star was a celestial clock marking the beginning of a new life cycle. In the indigenous traditions of North America, especially among the Navajo and Lakota, Betelgeuse also appears in stories about creation and the order of the cosmos. Some tales describe it as the burning heart of a mythical figure, while others associate it with divine signs or tests sent by the gods. For these cultures, the color and variability of Betelgeuse were living signs, almost as if the star breathed or spoke through its changing light. Can a star influence the fate of humanity? For the ancients, the answer was a resounding yes. In many places, Betelgeuse was seen as a cosmic sentinel, capable of sending signals about harvests, wars, or the births of great leaders. Its reddish glow, easily recognizable in the night sky, inspired respect and fear. Thus, Betelgeuse not only illuminated the firmament, but also the imagination of those who looked up and sought answers in the universe. Have you ever wondered how, long before the invention of GPS or even the magnetic compass, ancient navigators managed to cross seas and deserts without getting lost? The answer lies, quite literally, in the stars, and among them, Betelgeuse has been a fundamental celestial beacon for various civilizations. Its intense brightness and prominent location in the constellation, Orion made it an essential reference point for navigation at night. In the northern hemisphere, during the winter months, Betelgeuse appears as one of the most striking stars in the night sky. But why was it so important for travelers? Thanks to its reddish color and position, it is easily distinguishable even on partially cloudy nights. Ancient Mediterranean sailors, for example, used the arrangement of the stars in Orion, with Betelgeuse marking the shoulder of the mythical hunter, to orient themselves on long sea voyages. They knew that by locating Betelgeuse, they could identify east and west, thus adjusting their course with greater precision. But it wasn't just sailors who depended on this star. In the desert, nomadic Arab tribes used Betelgeuse as a kind of natural compass. On moonless nights, it was their guide in the vastness of the sand, allowing them to move safely between oases. For them, each star had a particular meaning, and Betelgeuse, with its orange hue, was associated with the beginning of certain seasons and trade routes. In Andean cultures, the appearance of Betelgeuse on the horizon signaled changes in the seasons, helping to plan harvests or important journeys. And how did they know exactly where they were headed? This is where the stars serve a function similar to traffic signs in a modern city. Betelgeuse, being in such a recognizable constellation as Orion, served as a starting point to identify other key stars and constellations. Thus, navigators could triangulate their position and determine the approximate latitude they were in, all by sight and without complex instruments. This skill, passed down from generation to generation, was essential for trade, exploration, and the survival of many peoples. In short, Betelgeuse has not only fascinated astronomers and poets, it has also been, for centuries, a silent ally of explorers and travelers. Its light, traveling through space for hundreds of years, has guided those who dared to cross the unknown. What other secrets are written in the stars, waiting to be discovered by new generations of explorers? Studying Betelgeuse represents a true challenge for modern astronomy. Why is it so difficult to understand all its secrets? First of all, distance plays a fundamental role. Although it is relatively close in cosmic terms, it is still hundreds of light years away from us. This means that any observation we make is like looking at an old photograph. We are seeing what Betelgeuse was like centuries ago, not what it is at this very moment. Furthermore, its enormous size and extended atmosphere complicate the acquisition of sharp and precise images even more. It's like trying to observe the details of a lantern through dense fog, where the light scatters and the outlines become blurry. Another significant obstacle is the inherent variability of Betelgeuse. This star is not a static object. Its brightness, size, and even its shape change over time. How do we distinguish between a fleeting change and a sign of profound transformation? Astronomers must make constant observations over years, even decades, to build a coherent story about its behavior. However, ground-based telescopes are limited by the Earth's atmosphere, which distorts the light and makes it difficult to collect accurate data. It's like trying to listen to a distant melody in the middle of a storm. The details get lost in the noise. The chemical composition of Betelgeuse also raises questions. Although spectroscopes allow us to analyze the elements present on its surface, the complexity of its atmosphere and the presence of enormous gas bubbles hinder the interpretation of the data. The outer layers of the star can hide or distort important signals from the interior, as if we were trying to see the contents of a box wrapped in several layers of opaque paper. This uncertainty forces scientists to use theoretical models, which often rely on assumptions that are difficult to verify directly. Finally, technological advancements are crucial, but they have their own limits. Although space telescopes and radio telescopes have improved the quality of observations, we are still far from capturing all the details necessary to fully decipher the fate of Betelgeuse. The current resolution does not allow us to clearly see smaller structures or rapid changes in the star. Therefore, each new observation is a piece of a larger puzzle, where many parts are still missing or do not fit together perfectly. Will we ever be able to overcome these challenges and reveal all the mysteries of Betelgeuse? astronomy continues to seek answers. Who is watching Betelgeuse these days and why so much attention? The answer is fascinating. Currently, Betelgeuse is one of the most monitored cosmic laboratories in the nearby universe. Various international teams have set their sights, or rather their telescopes, on this star, seeking to understand not only its present, but also to anticipate its future. Among the most ambitious projects is the collaboration between ground-based and space observatories, such as the Very Large Telescope in Chile and the Hubble Space Telescope, which examine its atmosphere, its changing surface, and the stellar winds that swirl around it. But how do they study such a distant and volatile star? One of the most innovative strategies is multi-wavelength observation. From visible light to infrared and radio waves, scientists are analyzing Betelgeuse as if it were a patient in a hospital undergoing various medical exams. For example, the ALMA radio telescope allows us to see the gas and dust that Betelgeuse expels, revealing details about its mass loss and the complex structure of its atmosphere. Meanwhile, missions like Gaia from the European Space Agency are refining measurements of its distance and movement, crucial data for understanding its evolution. There are also projects that use artificial intelligence to analyze millions of data points in real time. Why the rush? Because Betelgeuse could surprise us at any moment. Its anticipated explosion as a supernova. That's why networks of robotic telescopes, like the Global Supernova Project, are programmed to detect sudden changes in its brightness or spectrum. It's as if astronomers around the world are on alert, waiting for a signal that announces the great stellar event. Additionally, there are educational and citizen science projects inviting people from all over the world to monitor Betelgeuse's brightness from their own homes, contributing valuable data to the scientific community. Thus, the monitoring of this red giant has become a global and multidisciplinary effort. Each new observation, each small detected change, adds another piece to the enormous puzzle of the life and death of massive stars. Science is ready, technology is advancing, and the whole world is waiting for the next great chapter in the story of Betelgeuse. What if you could see a star so large that, if it took the place of the Sun, its surface would extend beyond the orbit of Jupiter? That's Betelgeuse. This colossal star is not only impressive for its size, but also for its peculiarities. For example, did you know that Betelgeuse is not perfectly spherical? On the contrary, its shape is quite irregular, almost flattened, due to the gigantic gas bubbles boiling on its surface, causing it to constantly change shape, as if it were a cosmic cauldron in a state of ebullition. Another fascinating curiosity is that Betelgeuse is one of the few stars that astronomers have managed to photograph beyond a simple point of light. Thanks to advanced telescopes and interferometry techniques, scientists have been able to capture images where details of its surface can be distinguished, something absolutely unusual in the universe of stellar observation. This allows the study of phenomena, such as the enormous dark spots that cover part of its atmosphere, similar to sunspots, but hundreds of times larger. Have you ever wondered why the name Betelgeuse sounds so peculiar? This name has been a source of confusion and evolution for centuries. Its origin comes from Arabic and originally meant the armpit of the giant, referring to its position in the constellation Orion. However, throughout history, translation and transcription errors transformed it into the forms we know today, making its name a kind of interstellar linguistic puzzle. And speaking of records, Betelgeuse also holds a surprising one. It is one of the fastest stars in losing mass in the galaxy. Each year, it expels an amount of material equivalent to several times the mass of Earth, creating a cloud of gas and dust that envelops it and makes it even more mysterious. This stellar wind is so strong that, in millions of years, the star will have thrown a good part of itself into space, contributing to the creation of new stellar systems. Who would have thought that such an imposing star could be, at the same time, so ephemeral and generous with the cosmos? Finally, there is an almost poetic detail. The light we see today from Betelgeuse began its journey toward us over 600 years ago. That is, Every time you look at Betelgeuse, you are actually observing a postcard from the medieval past. Thus, this red supergiant not only connects us with the mysteries of space, but also with the deep history of time. What does the future hold for the observation of Betelgeuse? How will we be able to further unravel the secrets of this colossal star? Today, astronomers are not only looking to the past, but are also preparing for a new era in stellar exploration. If Betelgeuse has already been the subject of study for centuries, technological advancements promise to take our understanding much further. The development of increasingly powerful telescopes, such as the James Webb Space Telescope, opens an unprecedented window to the infrared universe, allowing us to see through the dust that envelops the star and capture details impossible for previous generations. But what new insights will these instruments provide? Thanks to them, scientists will be able to accurately track changes in the surface and atmosphere of Betelgeuse, detecting ripples, material ejections, and temperature variations almost in real time. It's as if we had a thermometer and a high-definition camera millions of light years away, measuring every heartbeat of this red giant. Additionally, precision astrometry, driven by missions like Gaia, will allow for a more accurate calculation of the distance and movement of Betelgeuse through the Milky Way, refining models of its evolution and future explosion. And what if we could listen to Betelgeuse? Next-generation radio instruments such as the SKA radio telescope will allow us to analyze the waves emitted by the star, detecting faint signals that reveal both its internal dynamics and its interaction with its environment. Observing in different wavelengths, from X-rays to far infrared, will facilitate the three-dimensional reconstruction of the stellar atmosphere and the nebulae formed by the expelled material. In this way, we will be able to understand not only how Betelgeuse lives, but also how it sets the stage for its final destiny as a supernova. The future will also bring collaboration between ground-based and space telescopes, combining data from various sources to create a more complete and dynamic picture of Betelgeuse. Thanks to artificial intelligence, it will be possible to analyze vast amounts of information in search of patterns or unexpected signals that anticipate drastic changes in the star. What will happen when Betelgeuse finally explodes? Although no one can predict the exact moment, constant monitoring and cutting-edge technology ensure that when that day comes, we will be ready to observe, analyze, and learn from one of the most astonishing spectacles of the cosmos. Thus, the study of Betelgeuse will continue to be a driver of scientific innovation and a reminder of how much we have yet to discover in the universe. What makes a star like Betelgeuse so special? Its mere presence in the sky has fascinated humanity for centuries. It is not just a reddish light on the shoulder of Orion, but a true cosmic factory that reveals the deepest mysteries of the universe. Can a star change our understanding of the cosmos? Betelgeuse, with its colossal size and variable brightness, reminds us that the sky is full of surprises and enigmas waiting to be deciphered. Despite the distance that separates us, Betelgeuse has left its mark on science, culture, and even mythology. Why can such a distant star influence our stories and beliefs? The answer lies in its spectacular life and uncertain fate. This red supergiant has been observed by ancient and modern astronomers who have seen in it a unique opportunity to study the life cycle of massive stars. From its chemical composition to its pulsations and changing atmosphere, Betelgeuse is like a stellar laboratory at a glance. Will the day come when we witness its explosion as a supernova? No one can predict the exact moment, but the truth is that when it happens, it will be one of the most impressive events visible from Earth. If Betelgeuse were to explode today, its brightness could rival even that of a full moon for weeks. However, the distance that separates us ensures that this spectacle will be safe for our planet, but unforgettable for humanity. In short, Betelgeuse is much more than a bright star in the night sky. It represents the power of nature, stellar evolution, and humanity's connection to the universe. Observing it is peering into the origins of the elements that make up ourselves. What other secrets will the stars reveal to us in the future? As we look up, Betelgeuse invites us to keep exploring, questioning, and marveling at the vastness of the cosmos.